Prepare for a mind-bending voyage 10 quintillion years into the deep future. We are heading to an epoch where the cosmos itself is completely unrecognizable. The stars are dying. Monstrous black holes rule the void. And Earth, nothing but cosmic dust. But what lies beyond this dark horizon? Can humanity somehow cheat death and survive? First, let's grasp the sheer scale of this journey. What does 10 quintillion years even mean? Picture a 1 followed by 19 zeros. An unfathomable, staggering abyss of time. 10 billion billions of years. A number so massive it defies imagination. But there is no time to waste. We have an epic cosmic timeline to cross. Let's begin just 1 billion years from now, where a planetary nightmare is already unfolding. 1 billion years into the future. Earth is utterly unrecognizable. Our once vibrant blue oasis is now a scorched, barren wasteland. A dying, swollen sun has executed a slow-motion destruction of all terrestrial life. With every passing 100 million years, our star grows relentlessly hotter. Now, global temperatures have soared to a blistering 47 degrees Celsius, a lethal 117 degrees Fahrenheit. This extreme heat wave shattered the carbon cycle. Forests withered, followed rapidly by the collapse of the animal kingdom. Even the oceans, the cradle of life, boiled away into the atmosphere. A once thriving paradise reduced to a dry, decaying tomb. But what of humanity's fate? Ideally, we escaped our doomed cradle and colonized the stars before the sun's wrath consumed us. Yet, even Mars offers no sanctuary. The intensifying solar heat makes it a death trap. To survive, we must venture far deeper into the Milky Way, seeking refuge in distant star systems. Hopefully, by this era, our descendants will have perfected interstellar colonization. By then, Mars is ancient history. Perhaps the frozen moons of the outer solar system could offer a temporary shield against the heat. Or maybe survival takes a much stranger path. Imagine a future where humans transcend biology entirely, uploading their minds into digital networks. An immortal existence as pure artificial intelligence. Yet even virtual minds require physical power. We would still need a physical workforce to maintain the colossal megastructures keeping our digital souls alive. An eternal virtual existence sounds like the ultimate triumph. But surviving this cosmic shift will require energy and technology far beyond our current imagination, forcing us to adapt or face total extinction as we push even deeper into the future. Harnessing solar power requires converting direct current into usable alternating current. Now, a revolutionary class of ZVS inverters is completely rewriting the rules of energy. Operating at a mind-boggling 99.7% efficiency, this groundbreaking technology virtually eliminates energy waste, unlocking massive financial returns for green energy grids worldwide. This breakthrough is set to redefine future power systems, potentially shrinking electric vehicle batteries by 15% and slashing production costs by thousands of dollars. From Formula E racing to massive data centers, this energy revolution is already underway, proving that tomorrow's power challenges can be solved while saving the planet. But this is only the dawn of what lies ahead for our universe. Let us journey forward through the cosmic timeline, leaping 10 billion years into the deep future. As we emerge from this journey, the solar system is completely unrecognizable, transformed into something alien and cold. The sun is now tiny, about the size of Earth, and much dimmer than before. Over the last 9 billion years, the sun consumed all the hydrogen in its core. As its outer shell ignited, it swelled into a monstrous red giant. Finally, with its fuel exhausted and reaching the end of its life, it collapsed into a dying white dwarf. During its violent expansion, the sun's outer atmosphere engulfed Mercury and Venus, vaporizing Earth and leaving behind only a naked, scorched iron core. Now, this stellar remnant begins a multi-billion-year cooling process toward its final frozen state, a black dwarf. But the death of the sun is not the only cosmic catastrophe unfolding. Simultaneously, a colossal galactic collision was reshaping the heavens. Our home, the Milky Way, and its massive neighbor, Andromeda, both members of the local group, were pulled together by relentless gravity. Andromeda hurtled toward us at a staggering 400 million kilometers per hour. A spectator to this cosmic merger would experience a chaotic tempest, a violent cosmic snow globe tossing planets, rocks, and entire stars across the void in a dance of destruction. This went on for millions of years. When these two giants finally fused, they created a single supergalaxy, Milkomeda. Did stars collide during this cataclysmic event? Surprisingly, the answer is no, due to the unfathomable empty abysses separating them. We are talking about hundreds of billions of kilometers of empty space separating each star. Yet our solar system faced a dramatic fate. Calculations reveal a 50% chance that our home system was flung deep into the galactic outskirts, 3 times further from the new galactic core than ever before. Imagine a terrifying 12% chance of our entire solar system being violently hurled out of this newly merged galaxy. By that distant era, humanity will have long abandoned this doomed neighborhood. If our species still survives, we will have conquered and populated new worlds in a galaxy far, far away. Naturally, we would choose a peaceful sanctuary completely free from cosmic collisions. Prepare to bid farewell to the Milky Way and welcome the colossal new supergalaxy Milkomeda. But the cosmic drama does not end there. Let us travel 22 billion years into the future. The fate of existence takes a dark and complicated turn. A cataclysmic event awaits us, known to science as the Big Rip. A mind-bending theory suggests that in 20 billion years, the cosmos will literally rip itself to shreds. The culprit behind this destruction? A mysterious force called dark energy. This elusive power baffles the world's greatest physicists. Yet one terrifying truth is certain. It is accelerating the expansion of space at an uncontrollable rate. Keep this dark energy in mind because its power will only grow. If the Big Rip unleashes its fury, massive galaxy clusters will violently tear apart. Every single celestial object will drift into isolation. Stars, planets, and moons will hurtle away from each other at breakneck speeds. Ultimately, even individual atoms will be ripped to shreds, dissolving the very fabric of reality into absolute nothingness. Researchers have detected chilling clues pointing to this ultimate doom, though it remains far from certain. While that offers a brief moment of relief, let us assume the cosmos escapes this violent shredding. What lies beyond this threshold? 100 trillion years from today. Even if we dodge the Big Rip, the universe faces a slow, agonizing death. Over this unimaginable span of time, stars all across the cosmos will begin to fade forever. To understand this doom, look back to the dawn of time, the Big Bang. 150 million years later, the very first stars ignited. From that ancient spark to the present day, stellar nurseries have continuously birthed new suns. This process unfolds within massive clouds of interstellar hydrogen drifting through the void. These dense, chaotic regions, gravity triggers a violent collapse, igniting a brand new star. Throughout the next 100 trillion years, stars of every conceivable size will emerge. In the cosmic game, size dictates destiny. The smaller the star, the longer it survives. Consider a tiny object with just 8% of our sun's mass. Lacking the power to ignite nuclear fusion, it remains a failed star, a dim brown dwarf. Now behold a massive giant 10 times larger than our sun. Burning with furious intensity, it incinerates its fuel, doomed to perish in just 20 million years. While our own sun survives for 10 billion years, most stars in the cosmos are far smaller. These are the red dwarfs, ranging from 8 to 50% of the sun's mass. Though faint and dim, their lifespan is legendary, stretching from 80 to 100 billion years. Yet, even these stubborn survivors will eventually begin to fade away. Next are the brown dwarfs, objects so incredibly faint they are nearly impossible to detect. Their demise is slow and quiet, gradually freezing over eons. As they cool, their temperatures plunge to a relatively chilly 2,500 degrees Celsius. Finally, let us witness the spectacular end of a true monster, a star 8 times the size of our sun. A dying cosmic giant collapses inward, triggering a cataclysmic supernova explosion that tears through the fabric of space. What remains is a hyperdense neutron star, packed with unimaginable gravity. Or worse, its violent death could collapse it into a terrifying, light-devouring black hole. Across a staggering 100 trillion years, we have witnessed the golden age of starlight. We watched brilliant stars ignite and perish, alien planets vanish into the dark, and entire galaxies collide in a slow cosmic dance. But a silent, deadly crisis has been unfolding in the shadows of these stellar deaths. As stars expire, they eject cosmic debris into the void. While this dust sparks new stellar life, much of it is locked away forever. The universe is slowly starving, running out of the vital hydrogen gas needed to birth new worlds. Is this the ultimate death sentence for our cosmos? Fast forward 10 quintillion years. Welcome to the absolute edge of time. That is a mind-boggling one, followed by 19 zeros. The age of starlight is officially dead, giving way to a dark, haunting epoch known as the degenerate era. And no, this is not when chaos takes over the universe. Peer into the void, and you will find a chilling, pitch-black expanse. The vibrant cosmos we once knew has transformed into a silent graveyard. The universe is now littered with the glowing corpses of dead stars. White dwarfs, brown dwarfs, neutron stars, and black holes. Every single star that ever shone has finally burned out. With no new stars forming, what is the ultimate fate of humanity? Even if we escape to distant galaxies, we still need the warmth of a star and a viable home planet. Perhaps we will transcend our flesh and blood, surviving purely as entities of raw energy. A mind-bending thought. Or maybe we will escape to a parallel universe entirely. But first, let us return to this decaying reality. Watch closely, because rare, violent collisions still shatter the silence of this graveyard. When two brown dwarfs collide, they can spark a zombie star that burns for trillions of years. If two white dwarfs smash together, they trigger a blinding supernova explosion. Yet, these are just temporary sparks. The universe is freezing, growing darker as matter itself begins to rot. That marks the 10 quintillion year milestone. But the true horror lies ahead. What happens when the universe reaches its absolute limit? Let us travel 10 decillion years forward. That is a 1 followed by 34 zeros. We are now approaching the final gasp of the degenerate era. Even the toughest white dwarfs, brown dwarfs, and neutron stars are starting to perish. Their demise is triggered by a terrifying process called proton decay. The very atoms of matter are disintegrating, dissolving into nothingness. The last white dwarfs fade, glowing no brighter than a few household light bulbs. This slow-motion apocalypse takes an eternity, but in this dying cosmos, time is the only thing we have left. Watching the very fabric of reality dissolve is haunting. Even if it happens on a subatomic scale, the implications are devastating. If the fundamental building blocks of matter decay, the fate of all existence is sealed. As the last protons vanish, we must face one final, unstoppable monster. 10 duodecillion years into the future, the end is here. Imagine a number so massive, a 1 followed by 40 zeros. An unfathomable, terrifying void. We have descended deeper into the graveyard of the cosmos. And the universe is growing colder and more hostile by the second. No planets remain, no burning stars, not even the faint glow of white dwarfs. It is a realm of absolute, suffocating darkness. Only a ghostly, incredibly faint glimmer pierces through the shadows. These are the final masters of black holes. It is no wonder scientists call this grim epoch the black hole era. These cosmic monsters are massive gravitational traps, devouring everything that dares to drift too close. Even light itself is dragged into their inescapable grip. They act like celestial zombies, feeding on the corpses of dead stars, growing heavier and more dangerous. A force of pure, unstoppable destruction. But is it truly impossible to escape their clutches? Actually, there is one mind-bending exception. Scientists believe black holes might slowly leak tiny ghost particles. This mysterious phenomenon is known as Hawking radiation, and the way it works is absolutely mind-blowing. Quantum particles constantly pop into existence throughout space, instantly destroying one another. But at the very edge of the abyss, one particle is sucked in, while its twin escapes into the void. Over trillions of years, this slow bleed drains the black hole's mass, forcing it to evaporate and die. If we could fast forward through the eons, We would watch these titans slowly fade away into nothingness. But the cosmic clock never stops ticking, pushing us further into the deep future. As we journey toward the ultimate end of time, we must prepare for the final mind-bending phases of our universe. Let us step forward into the unimaginable scale of a googol years and beyond to see what shocking secrets lie at the very end of existence. Welcome to a googol years into the future. What does that look like? It is a 1 followed by 100 zeros. What is left of reality? Even the very last black hole has evaporated into nothingness. Welcome to the terrifying dark era. It is freezing, pitch black, and dead silent. What remains in this cosmic wasteland? Only stray subatomic particles and mysterious dark energy. Space has stretched so incredibly wide that these final particles are separated by light years. Once there were brilliant stars and massive black holes. Now you could search the entire expanse of our current universe and barely find a single speck of matter. A hauntingly desolate graveyard. And what about that dark energy? The mysterious force that threatened to tear reality apart. It will drive the universe to expand forever. As it expands, it freezes. This is the terrifying big freeze. All energy dissipates, and temperatures plummet to the absolute edge of zero, an icy tomb of absolute stillness. While this points to a cold, dark demise, another theory promises a violent rebirth, the Big Crunch. Instead of expanding forever, gravity pulls everything back, reversing the cosmic expansion. Imagine time running backward, rewinding the history of the cosmos. Galaxies collide, stars compress, and matter collapses back into a single point. If this happens, the entire Big Bang could trigger once more, restarting the cycle of life. Or perhaps this cosmic drama has played out before, in a never-ending cycle of creation and destruction. Sadly, top experts fear a much darker reality. A mysterious, suffocating force called dark energy is dragging everything toward a terrifying frozen doom. What hope is left for humanity? Long before the final freeze, the universe will enter a pitch-black era where survival seems absolutely impossible. A terrifying prospect. Without the blazing warmth of stars, life simply cannot exist. How do we escape this death sentence? One mind-blowing solution is to engineer our very own cosmos, created in a lab. Remember, our technological journey has only just begun. In the deep future, we will possess the godlike power to reshape reality itself. Human ingenuity will conquer the cosmos. As we ascend to a god-tier Type 7 civilization, the possibilities become truly limitless. But that is a mystery for our next deep dive.